Thank you. Welcome to part 2. In the first part of our lecture with demonstration, we discussed about Ohm's law, where we connected a battery to one lamp and measured the current. We also measured the voltage over the lamp. We later connected 3 lamps in series and also studied the current there. We saw that as we increased the voltage, the current increased, and as we increased the number of resistors or bulbs, which increased the resistance in the lower circuit, we got lower current. Now I'm going to demonstrate by connecting 2 lamps in parallel. 2 lamps in parallel. So here we have, if we connect 2 similar lamps to the same battery, because you see the battery poles are connected to these points, and this bulb is getting the same voltage here or there. I can bypass the amperemeter because amperemeter has negligible resistance, so we can use it. It doesn't almost have any resistance, so it doesn't theoretically affect the circuit. So we will see what happens when I connect the 2 lamps. Will they be equally strongly lighting as it was not the case here? And we will also see what will be this current compared to this current. And then we will see, will the lamps affect each other? If you unscrew or disconnect one lamp, will that affect the other lamp? So this is what we are going to see in the experiment now. Okay, we have the same instrument. We have a power supply. We have our multimeter, which we are using as an amperemeter, and we have another multimeter which we are going to use as a voltmeter. And we are connecting, let us say, the power supply to the bulb. We are connecting through the amperemeter, so we will be able to see the current also. Now we see that the bulb is on. We have 30 volt, and we have about 80.75, about 80 milliampere. So about 80 milliampere current is passing through this bulb. Now I want to connect another bulb parallel. Parallel means the other bulb should be connected to the same voltage. Now parallel does not mean it has to be geometrically parallel. It can be, of course, like let's say I have geometrically parallel. When I have these 2 connected, placed parallel to each other, then I can have the points connected here. And of course we see that the bulbs are equally bright, but it doesn't have to be placed that way. We could have a parallel connection even when they're lying on the same straight line, as long as they are connected to the same voltage. Like let's say I have here the plus pole to this one and the minus pole is to that one, and the third one is also, so this is also parallel connected. Now we see that all 3 bulbs are equally bright. Now we have, when we had one bulb we had 80 milliampere. Now we have 3 times more. 244 milliampere. Let me take out one. The other two are not affected because they are connected to the same voltage independently. And the total current is now 160. So total current has decreased. Let me take out the other one. Then I have unscrewed, that means disconnected. I can remove altogether. I have only one bulb and that gives me about 81, 82 milliampere. I put them back, equally bright light, but the current has doubled. I connect one more, equally bright light, and current is now 3 times more. Now, of course, if I have a battery and I am using 3 bulbs which are connected parallel, of course the bulbs are equally bright, but then we understand that the capacity will diminish, will come to an end quicker because 3 bulbs are using the same voltage. So this is what the parallel connection is about. Parallel connection means they are connected to the same voltage, and as they are connected we have 3 times. 3 bulbs means 3 times more current passing through the amperemeter. That's it. So we should think about when we are lighting at home, then of course they are parallel connected because a bulb fused in one room should not affect the other. Alright, thank you very much.